VALCRI implements a powerful analytics engine that is able to process lots of data records collected from different data sources. It integrates advanced machine learning techniques with interactive visualizations in order to facilitate data exploration and knowledge extraction. The data ranges from structured offender records to semi-structured crime reports, from static video clips to real-time data streams.
So VALCRI leverages the latest in semantic web technologies to combine and detect patterns in structured data streams. As an example, in the UK alone, millions of vehicle observations are recorded every day by sensors, and analyzing that data for an analyst unassisted would be impossible. But using these technologies, we can combine these observations with background knowledge and detect these patterns with sub-second delays. In VALCRI, crime cases are associated with video files, and the VALCRI system allows us to automatically extract structured information from these videos and combine that with the rest of the data.
Associative search extracts multi-level association among the crime entities. These crime entities could be suspect list, co-offender network, and unsolved crime. These are based on associative questioning approach, which is implemented with a 5WH model. Data mining techniques are incorporated and associations are extracted, then later visualized in a form of a knowledge graph. The knowledge graph represent spatial, temporal, and modus operandi association of the crime entities.
The Concept Explorer applies different dimensionality reduction and clustering techniques to compute groups of similar crimes. The novelty is that the Concept Explorer is able to compute algorithmic variants interactively and on demand. The crime clusters can be explored in a tabular component that we developed in close collaboration with the domain experts. And on the other hand, the spatial similarity and distances of the crime clusters can be explored in the similarity space selector. Direct manipulations can be used to apply feature importance weights, and this will cause recalculation of the clustering, which can be observed by the users. And this allows them to evaluate the robustness of clusters across different algorithmic variances.
In VALCRI, we analyze the MO text, which is like a description of what happened at a crime scene. For example, how a burglar went into a building or exited. And to do that, we are actually employing state-of-the-art technologies of natural language processing, machine learning, and put that all together in something like a domain-specific text analytics framework. We face a big challenge in terms of the data quality, because, for example, we can't really employ semantic text processing, something like identifying phrases and stuff like that. So it's really tailored to what the data is coming in terms of, for example, spelling errors, domain-specific language, which is really hard to process with state-of-the-art technology that's not tailored to the intelligence domain.
So in VALCRI, we do mine for sequential patterns because what matters for the criminal analysts is the order of the extracted concepts. So for example, in a MO node, the crime analyst wants to know how the guy entered, for example, through a smashed window, and then he does an untidy search and walks out through an unlocked door or something like that. If those concepts appear in another order, the crimes are not the same, and we try to figure out this similarity. We do have several components, like the S4 component, where the user can observe how similar different sequential patterns are. And with other components like the pattern selector, he can just get an overview of all the features that are there. And in, for example, the CCT, he can get it all together. So he can analyze directly what features, what sequential patterns appear in what crimes.
All those data extraction, processing, and analysis components form the key building blocks of the VALCRI project's analytics layer. All those methods are tightly integrated with interactive visual analytics methods like visual explorations, interactive feedback, and this is all allows reasoning and sense making on heterogeneous data sources.